Answers to assignment questions. Question 13. Give one reason why rubbing alcohol was used to make the homemade thermometer. Rubbing alcohol was used because it expands more than water. So when it is put into high temperature, it expands. And so it produces a larger change in the length of the liquid in the column. In this way, we say that it increases the sensitivity of the thermometer. Question 14. Explain in terms of particle motion why the length of colored liquid column increases with temperature. When temperature increases, the liquid particle gain kinetic energy so that they vibrate faster and faster. Each particle then occupies more space, and so the spacing between them, the separation between them, increases, and so the liquid increases in volume. Note that it is the liquid that increases in volume. The particles, they don't increase in volume. Particles never expand. A particle can only move faster and then occupies more space when it has higher kinetic energy at higher temperature. Question 22. An amount of thermometer is put into ice-water mixture and boiling water in turn. The length of the liquid column is 2.6 cm and 8.4 cm respectively. Then it is put into hot oil. At that time, the length of the liquid column is 12 cm. You may apply equation 2 to find the unknown temperature T of the hot oil. And it would be something like 160 degrees Celsius or so. Question 23. This thermometer is first put into ice-water mixture. At that time, the length of the liquid column is 2.2 cm. And then it is put into tap water at 28 degrees Celsius. At that time, the length of the liquid column is 3.6 cm. What should be the length of the liquid column at 100 degrees Celsius? Again, you use equation 2, but at that time you don't know the length at 100 degrees Celsius, and so you put it as a variable in the equation, and then you may find the answer like 7 point something cm. And don't forget to give a unit to your answer. Question 24. In this question, there is a faulty thermometer, and then it is put into ice-water mixture and boiling water respectively to give a reading of 10 degrees Celsius and 80 degrees Celsius. Since the thermometer is faulty, these temperature readings are obviously wrong. However, the thermometer looks like a ruler, and so we may take it as 10 units of length, 80 units of length, and finally when the thermometer is put into an unknown temperature, it gives a length of 30 units. In this way, then we may apply equation 2 again. In this way, taking the 10, 80, and 30 as length of liquid column. And so you may also find the unknown temperature T.
Question 27. By making 2 improvements on the following thermometer, make another one which is more sensitive. A more sensitive thermometer should have a larger bulb and smaller bore. So it should look like this. A larger bulb may have more liquid inside, so that when temperature increases, the liquid volume increases more, and so the liquid column also increases more in length, which means more sensitive. Question 28. Explain why the bulb of a quick response thermometer should have thin glass wall. And the answer is because in this way, heat can flow easily through the glass wall, so that the liquid inside may expand and contract quickly, and that will give a correct temperature reading more quickly. So for quick response, the bulb should have thin glass wall And the measuring liquid should be a good conductor of heat, so that the liquid is heated up and it expands quickly. Question 29. Give one advantage and one disadvantage of having thin glass wall for the bulb. The advantage is the quick response to temperature change, and the disadvantage is that the bulb becomes fragile, so it is easy to be broken. Question 30. What about the stem? Should it also have thin glass wall? If it is thin, then the glass wall is weak and it becomes fragile. It may be easily broken. And more importantly, there will be a lot of heat flow between the liquid column and the surroundings through the glass wall. So the temperature reading would be affected and it becomes inaccurate. Question 31. Clinical thermometers are sterilized by alcohol, but not hot water. Why? Because hot water is usually too hot. It may break a clinical thermometer easily. A clinical thermometer is designed to measure temperature around normal human body temperature, 37 degrees Celsius. Any temperature higher than 42 may be too high for a clinical thermometer. It cannot withstand that high temperature and it will break easily. Question 32. Give one advantage and one disadvantage of mercury in glass thermometer. Advantage: mercury in glass thermometer responds more quickly to temperature change. Disadvantage: mercury in glass thermometer is more expensive. Question 33. Mercury in glass thermometer is more sensitive, but usually we give alcohol in glass thermometer to junior forms students. Why? Because mercury is poisonous. Alcohol is not. So if a mercury in glass thermometer is broken, the student may breathe in the mercury vapor and it is dangerous to them. Lesson 3, Section 1.6 to 1.8.
1.6. Temperature and particle motion. According to kinetic theory, all matters consist of particles, and these particles are in constant motion. They are moving all the time. The average particle kinetic energy increases when temperature increases. Now let's take a look at the three states of matters: solid, liquid, and gas. So let's have found at a lower temperature. When temperature increases, a solid melts to become liquid. When temperature further increases, liquid vaporizes to become gas. When temperature decreases, on the other hand, gas condenses to become liquid. When the temperature further decreases, liquid freezes to become solid again. Most solids are rigid because the particles inside cannot move. Particles can only vibrate about their mean position. They cannot move around. But for liquid particles, they don't only vibrate, they can even move around from one place to another. At a higher temperature, they are gas particles. They may travel at very high speed freely inside the gas volume. As we can see, when temperature increases, the particles move more rapidly, and the average kinetic energy of particles increases with temperature. And you may notice that liquid and gas, they have no fixed shape, and so liquid and gas can flow. Lastly, gas has no fixed volume, because the separation between particles in gas decreases when the gas is compressed. Spend some time to copy all these onto your notes. Let's take a look at question 39, which is a bit challenging. First, note that when two objects have the same temperature, their particles have more or less the same average particle kinetic energy. And what does kinetic energy of a single particle depends on? Kinetic energy of a single particle increases with the mass of the particle and also its speed. And so, when one of the objects has a lighter particle that has a smaller mass, but in order to have the same kinetic energy, the speed of that particles should be higher. 1.7 Thermometer. How does it work? So you know that particles are in constant motion. They are moving all the time, and their average kinetic energy increases with temperature. But note that it doesn't mean that all particles have the same kinetic energy. Some particles are faster, while some are slower due to the collisions between them. When temperature increases, the particle vibrates faster, and those particles then occupy more space. As the average particle kinetic energy increases, so on average, the spacing between the particles increases and then the object expands. But note that the particles itself does not expand, they only occupy more space. So how does a thermometer work? When you put a mercury glass thermometer into hot water, the mercury particles gain kinetic energy and they vibrate faster and faster, and then occupy more space. The separation between them increases and finally the liquid expands. The increase in volume then pushes the liquid up the column, and then the length of the mercury column increases, and that's why the temperature reading increases. So the temperature reading is actually a measure of the average particle kinetic energy. When there are two objects, they have the same temperature. That means they have the same average particle kinetic energy. 1.8 Absolute temperature scale. Its significance and conversion. Now we know that when temperature increases, the average kinetic energy of particles increases. But what about when temperature decreases? Now, of course, the particles then move slower, and so the average particle kinetic energy decreases. So what if the temperature further decreases? Yes, the particle will slow down more. Scientists find that eventually all particles will stop their motion at a temperature of -273 degrees Celsius. This is the lowest possible temperature in the universe. Scientists call this temperature absolute zero, or 0K, where K is a new unit for temperature called Kelvin. The conversion between the Celsius temperature and Kelvin temperature is not too difficult, as you can see on the right-hand side. Absolute temperature is important because it is directly proportional to the average particle kinetic energy. And what does that mean? That means when the absolute temperature doubles, the average particle kinetic energy also doubles. So refer to the following chart for the conversion between different temperature scales.